So the next command we are going to see here is sketch bend. To start with sketch bend, I have made one base flange here. I'll select this face and say sketch. We have to make one line here from where we have to bend this part. So I'll put up this line at distance of 70 mm. I want to bend this part from the left side and 70 mm distance at 90 degrees. That's why I've made this line here. Now we'll go for sketch bend sheet metal operation. Select the command. In bend parameters, we have to show the fixed face here. So I'll show this fixed face here. Whatever face you select for the fixed face, one dot will appear on that face indicating that this face is fixed here. Now give the required angle. I'll say it 90 degrees only. We have to change the direction, suppose, then click on this reverse direction. The direction will be changed. First we have here bend from center line option. So there are certain options given for the bend position. I'll select the first option here as bend from center line. You can see this bend is coming with reference to center line at the middle portion here. But if I go for material inside, this complete bend will come under this line, inside the line. If I go for the another option, that is material outside, only thickness will come outside the line here. You can see here, this thickness is coming outside the line. And if I want complete bend outside, then we'll go for bend outside option. So these are the three options given. First, material inside, second, material outside, and third one is bend outside. Suppose you want this bend at the center, you will go for neutral axis. If you want to change the radius, you can off this default radius option and go for the change in radius. But I will consider it as default radius only, that is 1.5. Say it OK. So now sketch bend is completed here. You can also bend this in this way. Take one random line. It does not need to start from the edge or end at the edge. You can directly make a random line and then go for the sheet metal operation and say sketch bend. In sketch bend again, bending parameters, I'll say this face as fixed face. The opposite face will be bended or sketch bend. You can reverse the directions here. I'll say it OK again. So this was the sketch bend command. If you want to see this part again in a flatten length, then you can go for this flatten option given here. I'll select the flatten. It will roll back the bends and show us the flatten view. Only bending lines will be visible here, that is this line and the other line. If you want to exit this flatten command, you can exit it directly. Again say flatten, it will roll back. But there is one more thing to be considered, that we cannot make cutouts for any operation in flatten view. This flatten view is just needed to observe how the part is shown as flatten. Other than this, we cannot go for any commands here. So this was flatten. I'll exit the flatten again and it will restore the positions. Now if I want to unbend these folds, then I'll go for unfold option here. Select the unfold option. It will ask for a fixed face. I'll say this fixed face here. Then it will ask for the bends to be unfold. So I'll select this bend. The selected bend will be highlighted in sky blue color border line. Say it OK. Now I've unfolded only one bend here. You can see the difference in flatten and unfold. That is, the bending area will also be shown in unfold, whereas in flatten only bending lines are being shown. So again, if I want to fold this part, we will go for the second option, that is fold. The fixed face will automatically get selected here, as we have selected for unfold option, same face. We just need to show the bends to be folded. So I'll show this bend again. I want to fold it again and restore the position. I'll say it OK. It will go for the same position again. So this is unfold command. This time we'll again go for unfold and fold. Select the unfold. Fixed face. I'll select both the bends now, first and second. Say it OK again. Both the bends are unfolded. To refold them again, fold command. Fixed face will be selected by default. Bends to unfold will be this first bend and the other bend. Say it OK again. So this was unfold and fold command here. Now what is the need of unfold here? Suppose if I want to make a cutout here on this bend shape, then I'll go for unfold. say fix face, select the bend and say OK. Now you can directly sketch on this face and go for cutouts, such as if I want a slot here, I'll go for center point slot, take this reference and make one slot here. Put up the values, I'll say it 45, bending radius as 5 mm. Press Ctrl and select both the points here, say horizontal, make them symmetric. And now you can directly go for sheet metal extrude cut option. Extrude cut option is given here also in sheet metal tab. You can go for extrude cut from this side, or else you can go for features extrude cut also. Both are the same things only. I'll say extrude cut. Only one thing, one more option is added here is link to thickness option. So it will cut only the thickness portion here. And now again I will fold it. Say OK. So now one cutout is been provided at the bend here using unfold and fold option. Again I'll say flatten. So this bending area will not appear here. Only lines will appear showing the bending lines. So this was flatten, fold, unfold and sketch bend. Next we will see here is jog command. For that I'll delete this sketch bend option here. And now for jog command also same thing. Jog is similar to sketch bend only. The process of making jog and sketch are similar. Only the difference is it will take two bends here instead of one single bend. It will form a zigzag bend here. For that I'll make one sketch. Select the line and put up the value here. I'll say it 55 mm. Exit sketch and jog. Select the fixed face. Select the fixed face here. We have to put the jog offset value here, that is 20 mm. Now it is taking as 20 mm. I want to change these values to 10 mm. Now the jog height it is showing here as 10 mm. So there are multiple options for taking the height. That is, first one is outside offset. It means this 10 mm is taking from the upper face of the plate to the upper face of the jog surface. Second one is the upper face of the plate to the lower face of the jog face. And the third one is, that is this face and the bottom face. So in this three different ways you can provide the height. Next is jog position. We have seen in sketch bend also this option. Now it is taking from axis bend. If I want to take it material inside, I'll go for material inside. All the bend will come inside the line. Second one is thickness outside. Now this thickness will come outside the line. And third one is bend radius. Say it OK. Now this jog has been completed here. So this was jog option given. We can see the flatten view. I needed to show one more thing here in jog command. For that I have made one sketch. I'll go for jog command. Select the fixed face. And you can see jog is coming here. Offset distance is taken as 10 mm. But practically when you see, there are two bends coming here. So the material should be deducted from the upper side and this flange position should come at the back side here, as the material is being taken by these two bends. But still it is coming coplanar to this face only. So to adjust that, one option is given here, that is fixed projected length. So if I put off this option, the material being deducted here in bends will be shown as it is. But if I don't put up the option here, then it will take the same length for the jog as it was in bottom. So this was very important point here. So you need to control this option as to show it in a natural position or in a fixed position. Say it OK. And here the jog is completed again. Next command we are going to see here is Lofted bend. It is similar to Lofted boss command. For that I'll take one new file. Earlier we have seen Lofted boss in features tab here. Again we'll go for Lofted bend in sheet metal. But there will be some restrictions. In Lofted feature, there were no restrictions for the sketches to be taken for the loft. Means you can take 1, 2 or 3 parallel sketches and then go for the loft command and loft the material. But in sheet metal there is a restriction only of 2 sketches can be lofted at a time. Plus the sketches should not be in a closed loop. It should be in an open loop, as well as we have to avoid the sharp corners in the sketches. So we'll go for lofted bend here. I'll start with the top plane, select the sketch, say center rectangle here. Put up the values for the required rectangle. I'll say 200 mm and this side as 150 mm. Select the fillet command and avoid the sharp corners here. It is compulsory to avoid the sharp corners for the lofted bend command. In lofted boss it is not needed there. Say it OK. We have to make it open loop, but now it is showing as a closed loop. For that I'll make one line, one center line, and then offset this line at both the ends. Say offset, I'll take a very minor value here, say as 0.2 mm, bi-directional offset on both the sides. Say it OK. Now I've taken this offset and line just to trim the object. So I'll make this as a reference line, both the lines, and then go for trim option. So we have trimmed the option, and now the sketch here, it is an open loop. It is not a complete closed loop here. Again exit the sketch, reference geometry and plane option. In first reference I'll select the top plane, as I need to make the sketch parallel to the first one. I'll take one plane here, say OK, and then go for the sketch command. Select the sketch, I'll make one circle, I'll say it 130, convert entities, and say OK. I'm converting these lines again here. Show it in construction mode. We have converted this line just because we want to trim the circle also here, as we want an open profile. No needs of fillet as it is a circular shape here. Say exit sketch, and all my condition for making a lofted bend are completed here. That is making an open profile, avoiding sharp corners, and only use of 2 sketches. More than 2 cannot be lofted here. So I'll go for sheet metal and lofted bend feature. In lofted bend, there are 2 ways for making this part by manufacturing method. First one is by bending or by forming. So we will see each one. First I'll use bend command here. The open point may be of left side or right side. Similar, the other opening point. If I have selected above the left side, I'll go for this option also, left side only. And the lofted bend is been created here. Now there are certain parameters to show the lofted bend command here. First one is chord tolerance. So you can see this symbol here. Chord tolerance means when you observe at the bottom, it is not a complete circular shape. Sheet metal is bended here in the form of chords. So the maximum distance from the sketch to the chord, it will come at the mid portion here. You can see here from one end to another end, one curve shape is coming, and the maximum distance between the chord and the curve shape, that is called as chord tolerance. So you can go for the chord tolerance. I'll put up the value here as 1 mm. So now this chord tolerance, maximum distance between chord and the curve is increased, that is 1 mm, but the sharpness of the loft is been decreased here. So if you want more sharp value, decrease the chord length here. I'll say 0.3 mm only now. As I will decrease the values, I will get more smooth lofted bend here. Second option given here is number of bends. So instead of chord tolerance, I can go for number of bends at each corner. Now it is showing number of bends at each corner as 2. That's why only 2 facets are being created here. At first corner this 2, then this second, then this third and this fourth. But if I create this loft in this way, the smoothness will not be there at the bottom side. So to increase the smoothness, again I'll increase this value here. Facet value I'll increase and say I want 20 bends at each corner. Now you can see the end side, the smoothness has been increased here, and then proper lofted bend with smooth edges will appear here. Next, segment length. Now this segment length option refers to the length of this portion from one end to another end of each bend. So I'll decrease the segment length to smoothen the part. So in segment length, we have to decrease this value. In chord tolerance also, we have to decrease this value. In number of vents, at each corner, we will increase the value so as to make this part smooth. Last one is segment angle. So you have to put angle between each bend here. So it is taking 30 degrees. The limitation for angle is above 5 degrees and below 90 degrees. So I'll put up the value here as 10 degrees. It will again smoothen the round portion here at the bottom, and the lofted bend will be created there. I'll say 6 degrees only here, and then say OK. The method we were using, manufacturing method, was bent, and these 4 options. At the bottom side you can see bending radius and sheet metal thickness parameter is given. If you want to change them, you can change them here. After completing, say it OK. It may take some time to resolve this, and now you can see one lofted bend has been created. So at the corners in each bend, the angle between two bends is 6 degrees taken here, and then made this part. So this lofted bend command will be used for making hoppers in sheet metal type. The other way, we'll see the other way now. I'll delete this lofted bend. Again go for lofted bend command. But manufacturing method, this time I'll select form 1. Select the profile similar way as that of bend. I'll select the left point of the above sketch, same as the left point of the below sketch. Don't go for alternate point selection. It will not make a loft. Instead, it will show an error there. So similar side points are been selected and lofted bend using form command is been made. It is very simple to make by this method. Say it OK. And now this lofted bend is completed here. I'll make it flatten. You can see here in a flatten view also. Now I'll show the practical images of lofted bend where we can use in sheet metal. You can see this part. This is also made by lofted bend only, and then flatten. Again we'll return to software. Exit the flatten view. So this was the lofted bend feature here. Next feature we are going to see here is vent option. Sheet metal vent. For that I'll make one part. Suppose I need to make one control panel box there. So I'll go for the sketch, front plane, say midpoint line, put up the values required. I'll say 300 mm. Go for sheet metal base flange, put up the thickness as 1.5 and extrude it by 150 mm here or 200 mm, and then say it as mid plane. Reverse the direction of thickness. Bending radius it is taken here as 1.5 and thickness also 1.5. Then we'll go for edge flanges here. Select the edge flange. Select all the corner edges. You can either select upper edge or lower edge. Both are applicable there. It will provide same height only. Put up the height here as 90 mm. Say it OK. I'll again go for edge flanges. Select the flange and I will move it in the inside direction here. First, second, third, and the last one. As we take the direction inside, it will by default take the miter joint here. But if we change the direction by flipping the direction option, it will not take miter joints there. That time we are going to use miter flange option if you want outside flanges with miter joints. But this time I am going to go for inside flanges with miter joints, which is possible to take by inch flanges. I'll say it OK. Now again some flanges, I'll add edge flanges again with vertical heights first, second, third, and the last one. Say it OK. Now one control panel box has been made here. I want to provide one vent option here. Now the purpose of providing the vent, so as the air will ventilate inside the box and all the internal parts inside the control panel will be at a certain level of temperature only. It will not exceed the temperature there. That's why we provide vent here. So I'll select the face and say sketch. I'll select one circle here, put up the value. I'll say it as 68 mm. Define the sketch by positioning the sketch. Put up the required values 50. Now I'll say it offset by 10 mm or by 7 mm. Instead of bar direction, I'll go for only one direction. Say it OK. Now for vent I have made these circles. Next I'll go for lines here. I'll make one line and make this line pattern, circular sketch pattern. Parameters I'll select the center point, and entities to pattern I'll select this line and say 6 entities I want here. Say it OK. Now sketch for the vent command is completed here. I'll exit this sketch and select the vent command from sheet metal tab. In boundary we have to show the outer circle only. It will automatically cut the part here. You can see here. And now we'll go for the other options, that is ribs. So in ribs we have to select only that entities which are connected to the outer boundary here. So the entities which are connected to the outer boundary are the lines here. I select these lines as ribs, then provide one thickness value for the ribs. I'll take it as 2 mm. Then we'll select spars here. So you can select spars for the last option also here, or you can select that last option as a fill-in boundary so as to pack this portion here. It will be complete filled up here. So for both the options you can use the last sketch here, that is for spars or for fill-in boundary. One more option was given upper side, that was this radius option below the boundary option only. So I will provide this radius as 0.5 mm here, and all the corners will have the sharp edges removed and radius been provided here as 0.5 mm. So there will not be any sharp edges or corners here. I'll say it OK. And now this vent is been created. I'll hide this sketch here. You can see one vent is been created in sheet metal. So this was vent command for you. We will continue sheet metal in further lectures also. Previously we have seen 2 lectures for the sheet metal. You can go for the playlist option and study the earlier commands there. Please do like, share and subscribe the channel for more content. Thank you.